This is grade 7, module 15, lesson 4. Our I can statement for today is I can use a simulation to test the probability of simple and compound events. So here we'll talk through this first example. We have a softball player gets a hit 30% of the time she bats. So find the experimental probability of her getting a hit at least 2 times. So we're trying to find experimental probability of her getting a hit at least 2 times in her first 3 times at bat in today's game. So out of the first 3 times she hits, she wants to get a hit, or first times at bat, and she wants to get at least 2 hits. So design the experiment using the whole numbers from 1 to 10. So here getting a hit would be 1, 2, and 3. That would be that 30% that she was talking about. And then here we would have our 70% on the side. So label slips of paper, and again, you could really try this. Pause the video, go get a piece of paper, get a little cup. Label the slips of paper with whole numbers 1 through 10, because we're really going to try this. Place them in a cup, and then what you're going to do is draw a number, record it, and then place the number back in the cup. So that's really important. Put it back in there, or it'll mess with your probability. Use this process to generate 100 trials of 3 random whole numbers from 1 to 10. And then if a 1, 2, or 3 occurs at least 2 times in 16 of the 100 trials, then that experimental probability will be 16%. All right, so here we have Donna. She wants to generate random numbers to simulate an event with a 60% chance of occurring. Describe a model that she could use. So first we'd want to write our numbers. We're going to write our numbers. Numbers 1 to 5 on a piece of paper, and we're going to put them in a cup. And then we're going to draw from that cup and replace it. Draw from the cup and replace it. That's super, super important. You replace it back in the cup after you draw it. And then again, a 1, 2, 3, 1, 2, or 3 represent a successful outcome. And 4 or 5 would represent an unsuccessful outcome. All right, again, we're trying to get that 60% chance of it occurring. All right, so I want you to try number 2. Pause the video. What would that look like? What numbers would we generate? How many trials would you do? We have the known rate of defective phones at a plant is 1%. Draw a model an inspector can use to find the experimental probability that more than 1 out of 100 phones inspected will be defective. So pause the video. What would that look like if you wanted to draw that model? Hit play when you're good. All right, so we would generate random numbers 1 to 100 first, and then have 100 represent, that's the defective one, defective phone, and 1 to 99 not defective. So those are the good phones. We're gonna run we would need to run 100 trials. And with 100 numbers in each trial. Okay, and then we need to, what we'll end up doing is count the number of trials, where that 100 appears more than once. Count the number of trials where 100 appears more than once. Okay, so that's going to be our important part. Count the number of trials where the 100 appears more than once, because that 100 is that defective. So we're trying to figure out what that probability would be that we would see that phone more than that 1%.